for this final problem, we are going to take a look at having some information about an ellipse, and we want to write the equation in standard form. So this is one example, and you'll see something similar to this in your homework. So an ellipse is centered at the origin with the foci at the points 0, 2, and 0, negative 2. And that alone is enough to tell us the direction of our major axis. Okay, so if I just start making a sketch of this ellipse real quick, okay, I know that the focus points, these foci, 0, 2, and 0, negative 2, those are along the major axis. So that means I have to have a vertical major axis here. Oops. A vertical major axis. All right. And we were told that we're centered at the origin, but we didn't necessarily need to be told that piece of information. If we were just told that the focus points were right here, the midpoint between them, using midpoint formula, would tell us exactly where the center is, okay? Because the center is always smack dab in the middle of the focus points or any pair of vertices, okay, that are along the same axis, okay? So we have a vertical major axis, we have a center at 0, 0. So because there's a vertical major axis, that means we're looking at x squared over b squared plus y squared over a squared is equal to 1. That's what our function is going to look like, or rather our equation. It's not a function. It doesn't pass the vertical line test. Okay, so this is going to be our setup. The bigger number will be under the y squared. So the question now is, well, what's a and what's b? Okay, well, we know right here, it tells us now that the major axis is 6 units long. So if the major axis equals 6 units, that means from the center up and the center down, that grand total distance is 6 units. So I need a total distance here of 6 units. So that means this is at 3 and this has to be at negative 3, again because they're centered around the origin. Okay. You could also use the fact that the major axis is 2a units long and find that a must be equal to 3. Okay. So now we know the value of a. We need to know the value of b, okay? But the only piece of information that we have is that c squared is equal to a squared minus b squared. Now, if we know a and c, we can easily find b. And we do know a. We know that that's 3 squared. The question is, what's c? And c is the distance from the center to a singular focus point. So this distance right here, this is c. This distance here is also c. So you can think of it as the distance between the two focus points is 2c. Well, this is 2 units up and this is 2 units down, so c must equal 2 for this particular problem, okay? So I can use that right here. So what I really have is I have 4 is equal to 9 minus b squared. And for the formula, truth be told, I just need to know what b squared is. I don't really need to know the value of b itself. I just need to know the value of b squared. So what I'm going to do is I'm going to subtract the 9 over, which is going to give me negative 5 equals negative b squared. So that means b squared must be positive 5. Okay? So if I just take that standard form and fill in the blanks, fill in the 2 unknowns, x squared is over b squared, which is 5. Y squared is over a squared. A is 3, so a squared is 9, and that's equal to 1. All right? I highly recommend when you're given these verbal descriptions to start diagramming out the ellipse, even if you don't draw the whole thing. But it's really important to remember things like the major axis is 2a units long, and the minor axis is 2b units long, and the distance from the center to the focus point is c. All right, those are going to be really important things for you to know. And remember, if the center isn't provided, but you're given the pair of focus points or a pair of vertices, the center will always be the midpoint between those 2 given points, okay? So that's how you can write an equation given a verbal description. Again, diagramming along the way will be very helpful.